Hey everybody, this is Ted Petrou. I'm here to give you the webinar on how to formulate a routine for doing data analysis. And we're just going to wait just a minute or two for people to kind of join in and find us. I just sent a tweet out. So we'll just wait a minute or two. Now, while you're waiting, if you want to follow along live and actually do the programming with me, you can navigate to my GitHub profile, and I put the link in the chat. So if you guys can find the chat box, you will find the link. It's in this Learn Pandas repository under my GitHub profile, which is TD Petrou. So you should be seeing my screen, and you can see the URL hopefully, but easier, it's in the chat. So if you go to the chat, you should be able to click on that. And all of them, so actually this Learn Pandas has quite a bit more than just this data analysis routine webinar that I'm going to deliver today. So this is sort of where I keep most of my public Pandas material. But today's lesson is going to be in the data analysis routine folder. So if you go in here, you will get all the material. Now, what you would want to do actually is go here to clone or download, and you can download all the material like this. If you have a GitHub account and you're savvy with GitHub, then you can clone the entire repository and go from there. All right, so that's my GitHub. Now, if you have questions, you can ask questions. There's a box for questions here, and you can ask me questions, and I believe I should have some time to answer some of them. I'll have a break when I go between my slideshow and the live coding, and possibly answer some there. And then I'm actually free. I'll be free for quite some time after the my formal presentation to go through any questions that you guys have on Pandas or the routine I want to show you today. So if you have questions, feel free to go ahead and put them in that box, and I'll get to them at some point during the webinar. All right, so let me just go ahead and get started. All right, so I'm going to start with a slideshow, a little presentation, just to kind of.
Ted,
yes.
we can only see the poll screen.
Oh, you can only see the screen?
Just the polls. I can't see the slides.
Is that better?
No.
No. Can you see it now?
No.
Can you close it? Can you close the poll?
I'll close the poll. Okay, I'll close the poll for now.
There you go. That's better.
Okay, so apparently you can't have the poll on at the same time. All right, thank you for that. All right, let me start the slideshow, and then I'll get to a live coding demo. So it'll be about a 15-minute slideshow, followed by about 30 minutes of live coding or more, and followed by questions and answers. All right. So yeah, the topic of the webinar is developing a routine for doing data analysis with Pandas. My name is Ted Petrou, and I am founder of Dunder Data. I'll give you a little more information about myself later. This webinar is being hosted by a consulting and training company called Wintellect. They do lots of corporate training. They also do consulting. They partner with Microsoft very frequently. They've written many books on Microsoft products, as you can see here. And here are just some highlights. I'm not going to go through all of them, but this is just some of the stuff that they do. And I have partnered with them for consulting and training as well. All right. So just a tiny bit about me. I am the author of a book called Pandas Cookbook, which is kind of a ridiculous title, but if you know pandas and you know about cookbooks in the packed publishing world, then it all makes sense. I founded a training company myself called Metadata, where I focus on data exploration. So just the beginning of the analysis and training the fundamentals of data exploration programmatically, and concentrating on Python. I'm also the founder of Houston Data Science, which is a meetup group with about 2,500 members. We had many meetups. I actually don't live in Houston anymore, but the group is still going strong, and there's actually going to be a meetup, I think this week or next week. I used to play poker. I have a degree in statistics and chose to gamble for a little bit, and then came back to the corporate world after a little break. All right, so here's a little outline. We're going to identify. We're going to start off with you identifying what your routine is whenever you first get a data set, and if you want to change it. I'm going to outline my routine that I go through every time I get a new data set or a new project. I'm going to cover some of the basics of exploratory data analysis, which is part of the routine and is not the entire routine. And then I'm going to show you a demo with a particular data set. And then I'll take questions. So that's kind of our outline for today. Okay, so this is a poll. I'm not going to try to rerun the poll again, but I think some of you guys answered. But just if you haven't, just answer it to yourself. So these are meant to be questions that you can choose from, some responses. And so some of you may have a routine, some of you don't. Some of you have a formal routine, some of you don't. So it's just good to think about, like, what do you actually do when you first encounter a data set? What do you do when you first start a project at work or at home or whatever? And so that's what this talk is going to be about. And this is sort of motivated the talk, actually, was this book I read called The Power of Habit. And this is just very loosely based on this. But in this book, the author, Charles Duhigg, identified a core cycle that's part of all of our habits. It's called the cue, routine, reward cycle. And it's very simple. He broke it down in a very simple, just those 3 words. Basically, there's a cue that triggers us for a lot of our daily lives, for a lot of our daily activities. We have cues or triggers, and what follows is sort of an automatic routine that we may not be consciously aware of, and in the end we get some sort of reward. So in this aspect, the cue is, you're given a new project, a new data set, and that triggers you to do something, and hopefully there's some sort of reward by doing that. And you may not currently like your reward that much. Maybe you don't like the analysis that you're doing at the end, or you feel a little anxious because you don't know where to get started. So hopefully this, what I can show you today, might be able to help you enhance your routine to get a different outcome or reward. And if not, then you can still incorporate some changes if you don't want to have any dramatic changes. So this is just for me, what the reward of my data analysis routine. You might have a different reward. I have a scattered mind, and it helps me to follow a straightforward path so I don't branch off like in a tree, into many different leaves and leaving the core, untouched. So it helps me stay grounded, so I have less anxiety whenever I do when I follow this routine. It just feels good completing a formal set of tasks. It's nice to have a set of notes that I can refer to at any time, or I can pass on to others. It's nice to be organized and documented, and just to have a nice, clean system that I can follow and trust. And I can be more confident when I'm spotting data quality issues, which is a huge part of when you first ingest a data set. So a little bit more on my routine. It's just a foundation. So this is an important aspect of today's talk. It's not everything that I do. It doesn't go into every corner. It's just a beginning point. So because data analysis can be very complex and go off in many different directions, and this routine doesn't cover all that. It just covers a beginning point, a common ground that you can use when you get started. It is personalized for me. So my I guess hope is that if you do get something out of this, is to make your own routine. You can use mine as a template, and then to kind of form your own routine. Now, this is not to stifle creativity, this sort of routine. It's meant to actually give you more creativity, because you can reduce your need to kind of go into those little branches like I was talking about, and stick to the foundation at the beginning. And once you have that, you can feel confidence that then you can kind of take other steps. Okay, this might sound a little silly, but my routine is that I have to know from the get-go that if I am a data analyst and I'm looking at a data set, I am tasked with the job of finding something generally. Maybe there is a specific task, but if even regardless if there's a specific task or not, I want to be a detective. I'm going to find out what is going on with this data set, and I'm not going to basically let anything stop me. So I'm going to try to do what I can to extract useful information. The project genesis. So immediately once you have begun a new project or have a new data set, how do you start your environment? Who are you talking to? These are very key when you first get going. So there's a lot of non-programming stuff that goes on before you actually look at the data. Another part of my routine is I have a list of questions that I ask myself, and sometimes they're specific to the data. A lot of them are, the ones I have today are very generic, but I ask them and I answer them before I actually do anything with the data or before I look at them. Now, when I first begin looking at the data, and this might not take place for quite some time, I ensure I do very simple things. Creating a data dictionary is probably one of the most simple and useful things to do. Another thing is understanding what tidy data is, and we'll talk about that a little bit more, and to change your data into tidy data before beginning. And once I have just a basic grasp of my data set, and I have tidy data, and I have a data dictionary, then I can do what's more commonly thought of as actually doing data analysis, which is doing exploratory data analysis. And even with that, I have a simple methodology of just starting with univariate data analysis, and then I do multivariate data analysis. So essentially that's just going through one column at a time, if that's feasible, and then incorporating more than one variable. So I keep things simple and I steadily progress. And so that's sort of that's the foundation, and that's the end of my routine. So I don't have any guidance after this. This is just sort of to get the project going. Okay, so a little bit more on the mindset of a detective. It is your job, as the analyst. You have a lot of say. You need to be able to ask the questions. You need to have the courage to ask the important questions to the right people. And I see this a lot, at work, where there might be data scientists who don't have that wherewithal or courage to go find out the people who are in charge, the people who have more knowledge than they do. So I know this sounds very simple, but it's very important that you go out of your way to kind of investigate. Another thing is you can kind of think of as just making a documentary about the data. You're going to present this to someone, and it should be interesting and it should be accurate. All right, when you, at the very beginning of the project, a simple thing to do is, preparation of the file system is vital. If you're one of those people that has files scattered all over your desktop, I'm not one of those people. I can't be one of those people. That may work for you, but for me, I have to have a very specific place in my file system where I collect all my files and folders and notes. I collect data on the people that are connected with the project, and I'll show you a little bit of that. I have just a small template for that. One thing that I suggest is introducing yourself to the people connected to the project. Make sure you know them on a first name basis. You have their contact information. Meet them all. So here are just some examples of the people. Obviously, the stakeholders in the project. You as a data analyst is typically not a domain expert. You're usually there because you have the data analysis skills, not because you have the domain expertise. Other data scientists that may have worked on a similar project or have done work on it before. Where the data is coming from, the genesis of the data. Talk to the database administrators or the engineers. There's some other people, solutions architects, project managers. These are people. So basically, all the people that are connected to your project, you need to get in touch with, and you need to make sure you meet them and take that step to, form a bond with them so that you can, use them for your benefit. All right, so these are just basic questions. Whenever you get the data, this is before I look at the data. I'll ask these questions to myself, and I'll answer them if I can. What process generates the data? When was it created? How often was it updated? So I'm trying to get the history of the data set before I jump in. Where is the data stored? Is there a schema if it's a relational database? Is there a data dictionary? These are all basic things. Has the data been pre-processed? So what is the process that data goes through before it reaches your hands? Is it the raw data? What is the pre-processing? Who uses the data currently, right? So what kind of persons, groups, other software that are already ingesting this data, that are already, using this data in production? Those are good people to know, good things to know. And of course, if there's any previous analysts or scientists that have worked in the data set, it's good to know who they are and see what kind of work they've done. And one last thing is, like I said previously, is you're typically not going to have a lot of subject matter expertise, but as an analyst, it's still your job to get some expertise and to read, whether that means read articles, watch videos online, talk to experts. It's still your job to get some subject matter expertise, and that could be one of the biggest differences between producing a good data analysis is your subject matter expertise. All right, so when we first look at data, and I've said this multiple times already, is the data dictionary. And this is a description, and I'm going to go over this so you'll be able to see it. It's a description of each column, the data type of each column, and possibly notes, definitely notes in each column, and other attributes for each column. And this could be the number of missing values, number of unique values, the mean, median, standard deviation. Can also go in the data dictionary. If you're part of a relational database, it might be very useful to have the schema and how the data gets amalgamated with other data sets. Foreign keys, primary keys, these sort of things. I'm only going to briefly touch on tidy data. but it would it'd be very beneficial if you looked at tidy data. Hadley Wickham is a very famous data scientist and suggests putting your data in tidy form before doing an analysis. So this is sort of his first steps into actually analyzing data. And a quick summary of tidy data. So these are the tidy data principles. Each variable forms a column. Each observation forms a row. Each type of observational unit forms a table. And lastly, also you can feel free to rearrange the column order. That's actually very important. Other things when you're first looking at the data, so once you have tidy data, you can collect basic metadata for each column. Obviously, you need to know the data types. There's two main types, continuous and categorical. And sometimes you could think of dates as its own category of variable types. Missing values, knowing that percentage. This is just basic information to get you introduced to the data set. There's the 5-number summary, which was proposed by a statistician named John Tukey. It's very simple: min, max, medium, first and third quartiles for continuous variables. Categorical variables, you wouldn't be able to do this, but you can get other statistics such as the most frequent or the number of unique values. All right, so once we've looked at the data, then we're ready to begin exploratory data analysis, which is essentially just an approach that you can use to try to understand basic information about your data set without the formal use of statistics. So this is heavily relies on visualization. And like I mentioned, I like to start with univariate analysis. So one column at a time to keep it simple. And then I incorporate multiple columns. This will help you discover outliers, to investigate possibly at a different time, finding duplicate rows or columns, which is important. We're going to find some duplicate columns in our data set. So I have a table on different types of graphical and non-graphical methods that work best with each data type. So whether you have a categorical or a continuous variable, or two categoricals or one categorical versus one continuous, there's different common approaches, both graphical and non-graphical, that you can take. And continuously taking notes is very important in asking questions, not just coding. So during this process, you need to be writing and documenting and not just coding, because you will forget certain aspects. Okay, so the final product of just this routine, and this is not the final analysis, it does feel good to check off all the steps of the routine. And for me, it's very helpful to see the progress that I've done. You should be able to hand off your checklist report to someone else so they can see exactly what you did. Probably the most important person will be your future self, who's going to look at this. Everything needs to be neat and professional, and assuming that someone else will be using it. So since I use Pandas and Python, I keep, and not everybody likes this, but I like to use notebooks, Jupyter notebooks, that is, and to keep my exploratory data analysis. And you're not forced to use that, but that's a common thread these days. And then what kind of steps you're going to take next. So what things should be looked at more formally through different statistical modeling. So that's my final product from the routine. This is it. And it's just a starting point. So this is not the full data analysis. This is just a starting point to give me a solid foundation. All right, so we're finally here at the demo with the San Francisco Library data set. So I'm going to exit out of this little presentation, and I'm going to go to Jupyter Lab. So let me check real quick if there are any questions. Okay, so I think that was taken care of. All right, so I'll just keep going. You can feel free to ask questions if you'd like. All right, and hopefully you see a new screen. So if I don't hear anything, then I'll assume you see the Jupyter Lab screen. And this is from my GitHub repository. So this is a new kind of interface to doing work with Python. It's called Jupyter Lab. It's sort of the next generation of tools that will be that it's already fairly popular. But if you're accustomed to notebooks, then this is notebooks plus a lot of other different things. So you can have multiple different screens on here, windows that have a variety of different things. So let me just quickly show you what I'm starting with. So if I go to the San Francisco library usage, so if I'm in this folder, and maybe it'll help to go back to the GitHub. So if I'm here, if I'm in Learn Pandas, and I go to my data analysis routine folder, and I go to the San Francisco library usage. Actually, before that, here's my checklist. So let me stop right there. So my checklist is right here. And I'll just have to scoot it over. So so basically this is my routine. This is my formal routine that I have mapped out for myself and for the students that take my classes. This is sort of what we go through whenever we first encounter a data set. So it's fairly straightforward, but it helps us kind of have a set of checks that we can undertake and not kind of get lost. So I've opened that up over here as a markdown file. So as you can see, this is the exact same document. And all I do is I just start at the top and I go through my routine just like this. So we've already talked about being a detective. I have already, the genesis of the project. I've created a folder, and then one thing I do is, like I told you guys, I start a document to store names and titles of people. So I have a people document, and this is just extremely basic, but it's still good to keep track of the people that are associated with your project. So, so it's good to have a formal document that you can, write down all their names and their contact information. So that little template is in there. And that happens before you start the actual exploration. So we've already covered this in the slides. And then I start asking myself a bunch of questions before I start looking at the data set. So I don't know how well you guys can see my screen. I'll zoom in a little bit, so maybe you can see a little bit better. So if I'm looking right here, I ask these questions and I keep all the notes in a separate file. And so this particular data set I found on Kaggle, and Kaggle is typically known for being the home of data science, and it's more well known for its machine learning competitions. But in my opinion, the data sets section is actually quite a bit more more useful. And in the data sets section, if we can just quickly navigate to that page, you have a list of there's over 12,000 data sets where you can do exploratory data analysis and show your work and make it public, and then have people comment on it and discuss it, and you can comment and discuss on other people. So this is where I found the data. It was originally found from San Francisco's data portal. So you can visit that website. Most large cities have an open data portal that you can visit and collect data from the city. And I have the original data over there. So this is in the notes file. in that markdown. You can look at all this on GitHub, by the way. It should render just fine. And here's a short description, and let me close this window so you can see a little better. So here's a short description from the San Francisco, from the city on the data set. It is composed of bibliographic records and includes circulation data. And it has 420,000 records, and it's been collected since 2003. And so basically, and I just go, and I'm going to go, since I'm already kind of, it's already 2:30 my time, I'm going to kind of go through this quickly so we can actually see some data analysis. But anyways, the basics is that I write a bunch of questions and I answer them to the best of my knowledge at the time. And I answered some of these questions I couldn't answer, but the other ones I answered as well as I could. So I go through this sort of inventory of questions and I just write some basic answers, and it really helps to focus my brain and to get to know the data set much better. And if you don't do this, I think you're really missing out. For me, it's a necessity, and it really helps me out. Now, subject matter research. You might not think there's a whole lot of research on library, usage, but there actually is. There's an entire Wikipedia article on this, and library usage has actually increased dramatically, or not dramatic, but it has increased. And there's a lot more things to do at the library than just read books, as most of you know. I happen to actually really like going to the library myself, which is sort of why I picked this data set. So I just cherry picked some quotes from the Wikipedia article that you can read. I also went to I found an article from the Pew Research Center, and they do a lot of different studies on basically everything. And it shows just some a little bit of data on library usage. So so regardless of what the topic is, you can generally find some sort of research on it, some sort of subject matter expert who knows the topic better than you do. All right, so that's my notes over here on the right-hand side, and this is my generic checklist on the left-hand side. All right, so I'm down to the first look at data. So we're going to finally look at some data. This is my Jupyter notebook up here in the top left-hand corner. I just have some basic stuff: the start date, my name, a little summary. And what's cool about the Jupyter Lab is that it'll render CSV files for you. So here in the upper right-hand corner, I actually have, it's just one data set. It's 420,000 rows. It has rendered the first few rows for me. And I can see all the columns. I can even adjust the columns if I want to, but it allows me to keep the this data set open. I also have the data dictionary, which was also included with the data set. And this allows me to see precisely what each column is, what the data type is, and the description for each for each column. So this is nice. There's 15 columns, and it's nice to kind of have this readily available, so you can just look things up very quickly instead of, originally with a notebook you'd have to be scrolling up and down or changing tabs. But this Jupyter Lab kind of keeps it all together. And so, you can also make notes. If I can make this markdown editable, if I have more notes, I'm not going to do that. But you can do quite a lot of things on one page, on one screen. So it kind of keeps it all together, and you can, rearrange. You can rearrange these tabs in basically any kind of manner you want. Okay, so that's Jupyter Lab. And let's go actually look at this data set. So the vast majority of work can be done with just Pandas. So this is, this talk is specifically using Python and Pandas. Pandas has a hook to matplotlib, which is the primary visualization library of Python. But I also imported in a library called Seaborn, which can help make some nice aesthetically pleasing data sets. All right, so I'm going to read in this data set. And the first thing I do is simply just glance at the data, and it's just in a giant CSV file in the data folder, and I'm actually going to, let me see if I can enlarge this just a little bit, give it a little bit more room. Okay, so this is the head of the data set. Maybe that makes it a little bit easier. Just shrink the screen just a tad. Hopefully that's not too bad for you guys. All right, so yeah, just a quick look at the data. I don't necessarily need to do this anymore since I have the data set over here, thanks to Jupyter Lab, but this is what I'm used to, so I'm going to do that anyways. The next thing I'm going to do is load the data dictionary. So sometimes the data dictionary is in CSV, so I actually load it into a Pandas data frame. Now, if there's not a data dictionary, this is where you need to stop and create one, or at least start setting one up. And you don't have to use Pandas at this point. You can use any sort of spreadsheet that you like to kind of contain the data dictionary. The minimal viable product for a data dictionary is simply the column name, the data type, and the description. And you can add several more fields to that if you want, but that's sort of the minimum to make it a data dictionary. All right, so yeah, you can do it by hand or you can do it in Pandas. I'm going to show you how to do a data dictionary in Pandas actually, and how to upkeep it. All right, so here's the data dictionary. It's a CSV. It has those columns and it has an additional column for notes. This is just gotten directly from you know, from the Kaggle data sets. And I just put it in a CSV file. So there's nothing special going on here. This is just all the columns. So there's 15, and as you can see, it only goes down to 13. So something's already up, and we'll talk about that in just a second. Even data. So this is interesting. Even data that's sort of from the city itself, you'd expect to be more pristine, I guess, than some random data set. But it turns out that it's not quite what you see, and we'll find some interesting things right off the bat. You'll notice that you can't read all the descriptions, so I'm going to quickly change the column width, and now I'll be able to read the descriptions properly just by changing this max column width. So there's that. So these data types here are data types from the city of San Francisco. These are not Pandas data types. So what I want to do is replace these data types. This is the data dictionary. So when you see library DD, that's the data dictionary. Just library by itself is the actual data. So we're going to have two data sets, the data dictionary and the data itself. I'm just going to make a new copy just to have a Pandas data types. And here's a look at the actual data types that Pandas assigns to these columns. And what I can do is attempt to put in the Pandas data types right there. And then when I show my new Pandas data dictionary DD, lo and behold, I get nothing. I'm completely missing the data type. So something has gone wrong. And if you know about Pandas, then you would understand that it does something called automatic alignment of the index. And what it's trying to do is use these values right here. This is in the index, and it's trying to align them up with the values in the index of this data frame, and there's nothing that aligns. So these values are the column names, and these are just numbers, so nothing aligns. So what we need to do is what we're going to do is first thing we're going to rename the field name column into just column name, and then we're going to set this as the index. So now our index is not just the number, but it's the actual name of the column name. So the alignment should happen now if we do it again. So we're going to redo this operation and try to set this data type. That's the whole point. We're trying to set this data type correctly. And everything looks okay, except for this column. It's missing the data type. And it turns out that birth date is actually, it's in the data dictionary, as you can see right here. You guys can see it over here. It's in the data dictionary, but it's not in the actual data. They use the word age range. So whoever created the data dictionary had a name mix-up, or vice versa. And this is from a public Kaggle data set that from the city of San Francisco that you wouldn't necessarily expect this to happen, but it did happen. So what we can do is try to correct this. And another thing we can do is this is quite interesting, is that the number of columns in our data set, just library, is different than the number in our index for the data dictionary. So which is really bizarre, and you would expect these to match up perfectly, but they don't. So I say we failed the sanity test. So the data dictionary doesn't have all the columns in the actual data. So I thought this was quite interesting. So I wrote, I won't explain this, but basically this finds out the columns that are missing from each ones. So there's actually an entire column missing from the data dictionary called circulation active month. And if you look back at the data, you can see it over here. It's in the data itself, circulation active month, but it's not in the data dictionary. As you can see, there's only circulation active year. So I went ahead and first of all, I renamed this to age range. I renamed the index to age range. I changed it from birth date. And then I created, I inserted in a new column or a new record into the data dictionary called circulation AM. And you can look at this code a little bit more in detail. Basically, it's just opening up the data frame and appending this new column in it. So it's just an insert in. So now I have my circulation active year, and or circulation active month, and I changed the description as well. So if I go back up here, you can see that I gave it a new description, and this actually helps name it. This little pandas trick. Anyway, so as you can see, I've kind of corrected the data dictionary. You could have done this by hand in an Excel file or your favorite spreadsheet, but this is how you would do it in Pandas. All right, so can we finally align the data and just get the data types? And it looks like we have some success now. And all the data types are filled in, and all the columns have a description. So this is our data dictionary again, anything with DD. All right, one thing to notice here is to actually look at the data types and to make sure they make sense. So, and I looked at them, and if we look closely, we look at this circulation active month, okay, and looks like a string name, like it has February, July. Circulation active year appears to be numeric, but it's actually a string. And in Pandas, Pandas uses the data type object for strings. And so this is something we're going to get back to later. So you think it would be an integer, but it's actually a string. Okay. And I made a new note in the data dictionary over here. I just added to the notes column. So this is just a thing where I'm updating my data dictionary to keep it up with what I've done. And this is important. So whenever you make a change, you update your data dictionary. All right, so this is taking a little bit longer than I thought. So I'm going to try to kind of go through this a little bit quicker. So just to move on a little bit, you can get some metadata, finding the exact number of rows and columns. If you want to get a count of all the data types, you can see we have 8 object data types and so forth. The next thing I suggest, and I'm just following. So basically, I'm just following my outline over here from my routine. So just following the routine. So I'm not doing anything fancy or kind of deviating much. I'm just following the routine. I can get the number of missing values per column like this. I can actually append this to the data dictionary. So I can make an entire new column where I keep the missing values count. So I'm actually adding this to my data dictionary. So I've updated my data dictionary with the missing values like this. I made a new column directly with Pandas, which is very nice. So this is very helpful. And the key to making this work is actually setting the index. So if you set the index and make sure the index has the same names as your column names, then these will align and you will get this perfectly. If not, then you'll get what we originally did, which is a bunch of missing values. So that's why we had to do that alignment and change the index. All right. So we can also add percentage of missing values. So this is just another column with the percentage of the missing values. So I'm just building my data dictionary. Now, the next step on my list is to determine whether this data is tidy or not. And this can be tricky if you've not worked with tidy data before. But if we look closely, we'll notice that the data isn't quite tidy, and this is a very important point. Although every row, if you read from the description, is a single patron. So every row is a single patron. It has data on just that one patron. So it seems like every row is an observation. If you look closely at the columns, though, and I'll look over here. If you look closely at the columns, you'll see that there's actually several columns that have this word code and then definition. So like, let's just take this, for instance, this library, this home library code versus this home library definition. You'll notice that they look like they're mapping up 1 to 1. X maps the main library and so forth. So this looks like a duplicated column, which would render it completely unnecessary in our analysis. So what we could do is to figure out if there is an exactly 1-to-1 relationship, is to run this crosstab, which is just a two-way contingency table, and we count the co-occurrences of each pair. And if there is a 1-to-1 relationship, then we should see a bunch of zeros, and only one column, one row per column should have a number in it. And that's exactly what we see. And there are quite a few categories here, but it looks like there's a 1-to-1 relationship. And if you want to ensure that there's a 1-to-1 relationship, we can see if the sum of each column actually equals the maximum value of each column. And indeed, it's true for everything. So we have a 1-to-1 relationship. That means we can drop a column. So this column is actually unnecessary in the data set. It doesn't give us any extra information. And this is key if you're running a regression analysis and you have two columns that are correlated with each other, either 100% positive or negatively correlated with each other. You're not getting any extra information. And you can greatly bias your results or actually have algorithms that don't actually work. So having duplicate columns is a major pain and something you need to look out for. And doing a crosstab is one way to find these duplicate columns. So I just drop this column, and you can see the patron type. Okay, so yeah, I think I skipped around. So I was looking at actually patron type definition and patron type code. So I skipped over one. There's 3 sets of columns that actually do this, and so anyways, they follow the same pattern. There's a code, and then there's a definition, and there's a 1-to-1 relationship. So one of the columns is completely unnecessary. All right, so I do the same thing with this notice preference and notice preference definition, and you can see here without even having to do any sums or maximums, you can see that there's a one-to-one relationship. So again, I get rid of the code and I keep the definition, which has it has more information, which is why I keep it. So I'm slimming my data frame. I'm reducing superfluous columns. And trying to create tidy data. Now, if you stare at this a little bit more, you'll see one other thing that could be consolidated. And this is the dates, active month and year. And there's not really a reason to have a separate column for month and year. You can consolidate this into one column of just month and year. And so Pandas has many ways of doing this. And since they're both string columns, and we saw that from above in data types, we can concatenate them together, separate them by a comma, and then pass it to the toDateTime function, which will turn it into a formal Pandas date. And that's important because we get nice date-time functionality. With strings, you don't get any date-time functionality. So that's key to this. And before we do this, we can kind of look at the unique values, the value counts, to see what we have. And we'll notice that if we look at this circulation active month, this is good to do before you do any sort of concatenation. Check the actual values. We can see that there's a bunch of missing and none. And this is problematic because when we did when we counted the missing values from above, these did not get picked up as missing values. So if you go back up and look at the missing values, they did not get picked up. And that's because they were labeled as the string none, which Pandas didn't know about. And so we can actually read in our data with the read CSV function and tell Pandas we want none to be a missing value, but we didn't know that, of course, before this began. So the next time we read this in, we can force this to be an actual missing value, not the string none. Regardless, it actually doesn't affect us right now. What we can do is, to get the date, we can concatenate the month and the year, separated by a comma, and we'll get something that looks like this. So I save this to a variable, and then we give it to the, we can force it to a date time, so it'll look like this. And so this is what we get when we force it to be a date time. Now, this is a very slow operation, and we have 400,000 columns, so it takes a little bit of time. But so it's one by one converting these strings into date, which is phenomenal that it can read such a diverse range of strings and convert them to dates. So Pandas is doing a lot of nice things for us here, and converting a month, comma, year into a very specific date time column of data type. So we'll just wait a little bit until this completes, and shouldn't take too much further. Last time I did it. All right, so it just completed, and so now we're going to insert this new column into our data frame. So we're going to use this new column. The first thing we need to do is we're going to use the insert method. The insert method, you need to know the actual column location as an integer. So this is a method that gives it for us. And we're going to insert it at this location. We're going to call it this, and this is the actual data. So this is what took us like a minute to do, was converting it to a date. And we're going to go ahead and insert it in, and you can see here, and I didn't do library new. Here's the new column right here. So we have a new column of data, and it is specifically a date time. And Pandas has actually converted all the nuns into missing values for us. So now we have an accurate count of the missing numbers. All right, so that's how we can get rid of this. Now we can get rid of our old columns, our circulation year and month. We don't need them anymore. And there was another codes and definitions that I can get rid of. It wasn't exactly a one-to-one mapping, but it was close enough. So let me just quickly go through here. So basically, I'm just eliminating one more column. And so this is sort of my final data set. I've slimmed it down. I dropped 3 columns, and I added a single column. Actually, I dropped 5 columns, and I added 1 column to take the place of those 2 date columns. So now it looks more like we have tidy data. And here I'm going to clean up the data dictionary. I'm going to get rid of the old columns. And I'm going to add our new data dictionary. We're going to add this new column over here. So this is sort of our final piece before we get started with the exploratory data analysis. All right. And I added some notes. So here we go, add some notes. So I'm just doing some housekeeping and keeping up with my data dictionary and adding some notes over here. Actually over here, sorry, on the right-hand side for some columns. All right. So now it looks like we have tidy data. The last step that is important is don't be afraid to change the order of the columns. And so it's a lot of people will recommend that you put the categorical values on the left-hand side and the continuous variables on the right-hand side. But it's up to you on how you want to rearrange your columns. But it can help you read the data set. Because when you naturally see a data set, you read it from left to right. It's not like you just there is a way that humans naturally read data sets, and it's generally left to right, just like they read books. And so I suggest rearranging columns such that they make sense to you and that they make it easier for you to read. So that's all I've done here is I've rearranged the columns, and I'm just ensured that I haven't, I've typed everything in properly and I haven't duplicated a column. So I just make a new column order, and I made a few small arrangement. I moved the checkouts and renewals to the right a little bit, and I moved a couple other columns to the left. And these columns over here, I've sort of deemed them as not as important. Again, I haven't changed their order, so I just kind of kept them the same. All right, so I'm gonna so it's already 3 o'clock, so I'm going to, I didn't actually get to the exploratory data analysis part, but that is what I consider getting to tidy data and creating a data dictionary and taking the steps necessary before you begin the analysis. And that is the key point that I wanted to bring home, is that you set up an environment, that you create all that you need to to begin your environment before you actually start looking at data. And I believe that this will have a tremendous effect on how well your analysis goes from here. So the rest of this I go into is actually what I would, I guess, call exploratory data analysis, and I start with univariate descriptive statistics. And I'm going to stop there since it's 3 o'clock. I'll see if there's any questions, and if not, then I'll keep going for another 15 or 20 minutes with this univariate descriptive statistics. So let me just take a quick break and see if anybody asks any questions. Description for our circulation active year begins with month. Copy pasta. Not sure. Okay, yes. So the question is, do you document anywhere other than in Jupyter Notebook what you are doing to your data set when making your data conform to tidy data? So you can keep track of notes. I mean, it's all, always up to you. What I generally do, so in my workflow, and as you can see, I've already put in quite a lot of notes in here. So I've kept track of everything that I've done. So this is, I do intertwine my notes directly with the commands that I'm running. So this notebook should hopefully be very highly transferable to someone else if they want to see what I've done. So occasionally I'll write questions like over here if I want to get back to something later. I don't keep it in the notebook. I keep it in my separate notes page. But to describe the actual transformations, I generally keep it in a notebook. And what I make sure I do actually is I try to keep the notebook very clean. And in fact, what I'll typically do is create one sort of a very messy exploratory notebook and then create a different notebook that is sort of like a final copy, like a more formal report. So I can have one that is messy and one that is nice and neat. All right, cool. So I guess that that wraps it up. I'll keep going. You can keep asking me questions on anything. I'll answer the questions. I'll go through a little bit of exploratory data analysis. And I've documented exactly what I do for exploratory data analysis down here. So again, this is the roadmap, this markdown file that's called beginning data analysis routine. It has all sort of my basic routine that I go through, and that's what I recommend you guys change and kind of personalize to make it work for you. So, and this is sort of a nice little table that you can use that'll help you decide what sort of things are available to you when you do exploratory data analysis. So for instance, if you have a categorical variable and you want to make some sort of graphical representation, you don't have a lot of choices actually for this, but a bar chart of the frequencies is the most common thing to do, or you can do some sort of contingency table, which is just done by value counts with Pandas. And so you can see here, if you go through it has all the different combinations that you're going to encounter, or many of the combinations, and what to do for each combination. So for instance, if you go to the multivariate case down here, if you have a categorical versus a continuous variable, these are some common plots. These are actually from Seaborn that you can use that will help you, and there's a little bit, there's a link to it that you can use that will help you graphically display your data sets. And so you can sort of systematically go through this and try to find interesting relationships. All right, so I'll just keep going a little bit longer, probably another 15 minutes. And you can always feel free to ask me questions on Twitter, or I post on LinkedIn a lot under Ted Petrou. So I'm happy to answer any data analysis questions you have specifically on this routine. So let me just quickly drop down here. So I've ended tidy data. I've dropped some columns. I've consolidated another column. I found the missing values, found a percentage of missing values. I updated my data dictionary. I made some new notes. I have my notes from before I began, so I feel like I'm in a good position. I feel like I have a much better understanding of the data set already. And now I'm ready to actually look at some essential statistics. The describe method is a very easy way to get descriptive statistics. Typically, you do it for either categorical. It gives you two different views: one for categorical data, one for continuous data. So the O just stands for object. So I'm going to get all this data over here. There's 4 object columns. You can see the number of unique values. So you can see this is actually quite a useful column to kind of understand your data set. You can see the most frequent one and how often that occurs. This .t is just to transpose it. So to me, it's a little bit easier to look at. The nUnique function gives me the number of unique values for every column, regardless if it's categorical or not. So this also helps you get an idea of the distribution. And as you would expect, the continuous columns, like checkouts and renewals, have the most number of unique values. Now, you can add, this is kind of fun to do, you can add this metadata to your data dictionary. And now I have a new column that counts all the unique values. So I'm just expanding my data dictionary. May or may not be necessary, but it kind of keeps all the information in one place. And it's something that you can refer back to kind of help you wrap your mind about the data set. All right, here's a little tip on being efficient with categorical data. There is an actual categorical data type that you can use in Pandas. Basically replaces all the strings with numbers underneath, with integers. And it can save a tremendous amount of space. So in this instance, and especially since we have low cardinality data, which means there's not too many unique values, you can change them to category. They were object, and now you can change them to category like this with the as type command. And now, if I look at the D types, I can see that I have now categories and not objects. And I can update my data dictionary. I can see category, category, category instead of object. So I'm always updating my data dictionary. And if I look at the memory, and it's kind of hard to see by going back and forth, but the new memory usage is considerably less than it was. So if I look back up, this is like 2 orders of magnitude more than it was. So those columns have been shrunk by like 99% or over 90%, I would say. So that's a huge advantage of categorical data. Also, a lot of things become much faster because they're actually integers underneath the hood, and you're not dealing with strings anymore. So going back to the univariate analysis, if you have a categorical, you just look down here. We don't have much of don't have much choice. So a simple thing to do is just to find the count. If you use normalize equals true, you can get the percentage. So here's the patron type. So we have 64% of the population is an adult. 14% is juvenile, and so on. You can make a bar chart just to visualize it. You can see we have a lot of low numbers over here that are not even making a dent in the bar chart. And that's cause for concern as to why we have these categories that are such low counts and why they are not over here. So this is a question that that should immediately pop up. And so this is sort of what I would call an outlier in one dimension for categorical data. And I just titled it categorical outliers. And you can see down here that there's very few in number. So what I like to do is actually label these outliers. I actually like to label these outliers as a separate column in the original data set. So as you can see, these are the, as you can see, these are the columns, and this is just some Pandas trickery I did over here, but I've gotten all the columns, or all, not the column, I got all the values that have very low count. So you can label outliers in your data set. And the way I do this is by, I get all these values, okay? And I use the isIn method, and I make an entirely new column called patron outliers. And it didn't work because I didn't run the cell. And now if I look over here in my data set, I actually have a new column that's true or false that's going to find the rows that are outliers. So I can quickly access my outliers in the future if they're labeled in my data set. So that's something I like to do. And they don't have to be outliers. They can be anything you want. So they can be some kind of combination of things. You could be like, you could look for seniors with more than 25 checkouts, and you want to save them, so to speak, and you can have a column that is a Boolean column that labels them as such, so you can easily find them later. So that's a little trick that I like to do, especially with outliers. So that's an example with categorical data. If we go to continuous data, in one dimension, you have a lot more possibilities. The first thing I do is usually just run the describe method, and I get, let me just show you this first. So you get the 5-number summary, and it is possible to, I just didn't put the mean there for some reason. You can actually add the 5-number summary to your data dictionary. This can make it quite messy, which is what I warn right here. And anyway, so I've actually just done a little join to join this table to my data dictionary, and I've appended the 5-number summary to my data dictionary. Now, it'll only show up for those continuous columns. You'll have missing values for the rest. So this is why it's a little messy and a little bit misleading. But it's still something that you can do if you want to kind of contain all the summarized information in one single area. One of the main things to do with a continuous variable is to get a sense of the distribution. So a histogram is a great way to do that, and we can see that we do get some sense. We find out that there's some extreme outliers that are checking out things in the library at an extraordinarily constant rate, or a very high rate, I should say. And we can't see how many they are, but there are definitely some. That's why the data extends all the way over here. So this has already helped spot us some outliers. Now, generally a box plot is a better way to spot outliers. So if we use Seaborn, now I'm using Seaborn to create a box plot. You can see some outliers over here. And what I do typically, is actually just use my own human eye to kind of eyeball which observations I want to kind of look at in the future. So again, I kind of arbitrarily picked 5,000 as a cutoff, and I made this a column again. So I did the same thing with the categorical above and just made it an outlier column. So if I look at this, I added this to this, and this is actually how you could quickly search for outliers. So I actually skipped this step, but since this is a Boolean column, I can pass it into the data frame selection indexer to select just the outliers. So these are all ones that have more than 5,000 checkouts. And this is just a very simple way to do that. So I can quickly get all the outliers back and kind of examine them by hand if I wanted to. Okay, so that's my univariate analysis, and I stopped there because I knew I wouldn't have much time, and I could go on to multivariate analysis or other things that I have on my checklist. So So I have quite a bit more on the checklist that I would normally do, but that gets you all the way through univariate analysis for categorical and continuous variables. So that's all the information I have. But hopefully that that gives you a good starting point, some ideas to kind of change your routine. So let me check one last thing if there's any questions. All right. Yes, this webinar is published, it was recorded, and all the materials online on GitHub. So please look at that repository. I'll post it on Twitter in case you can't find it in the chat. All right, guys. Well, thanks a lot for showing up. You can find me online very easily. I'm very happy to answer questions on Pandas and exploratory data analysis. And hope you got something out of it. And the main thing is just have a routine, and I think it'll really help you out when you first get into a data set. It really, for me anyways, helps relieve a lot of stress and anxiety because I have a starting point. I have a clear road to kind of get some basic information from my data, and it really settles me down and helps, I think, produce a better analysis. All right.